Now I am having one video where which shows how the electron, how the covalent bond that breaks down, and that can the electrons are how the electrons are free, and the empty holes which are created by the movement of electron, how they are filled, and how the current conduction is carried out. Just see here. This is very fine video that will enable you for the clear understanding of intrinsic semiconductors. So here, see this video. So in this video, we have seen how the ion vacancies are created and electron vacancies are created, and the movement of electrons that carries the electric current. So this particular video enables us for the clear understanding of the intrinsic type of semiconduction that is known as pure semiconductors in case of silicon or germanium. So we are having two seminars. The first seminar that will be delivered by श्रुतिका नरोडे. श्रुतिका नरोडे जरासं व्हिडिओ चालू करायचा. मी व्हिडिओ हे शेअर करतो तुझं प्रेझेंटेशन, ते दिसते की नाही मला सांगायचं.
हां
दिसते तुला?
हां सर दिसते.
ओके, यू कॅन स्टार्ट.
Okay, sir. Good morning, all of you. Welcome to my seminar. Sir, next. First, I introduce myself. My name is Shrutika from BSc TY in Chemistry. Today, we will discuss about the topic Industrial Applications of Catalyst. Sir, next. In this point, we study about four different uses of catalysis in industrial process. First one is synthesis of ammonia. Second, manufacture of H2SO4. Third, Ostwald process of for nitric acid. And fourth, hydrogenation of oil. Sir, next. First, synthesis of ammonia. On industrial scale, ammonia is synthesized by the Haber's process, which is given by Fritz Haber, is a German chemist and got a Nobel Prize in 1918. In this reaction, nitrogen and hydrogen used as a raw material. Nitrogen is obtained by the fractional of distillation of air, and the hydrogen is obtained from cracking of crude oil. Cracking means breakdown of higher hydrocarbons into smaller ones, and the fractional distillation means separation of component of a mixture on the basis of difference in boiling point. In this reaction, 1 mole of nitrogen reacts with 3 mole of hydrogen in the presence of catalyst iron, and the molybdenum act as a promoter. Promoter means to improve the performance of the reaction. To give 2 moles of ammonia gas, it is a reversible reaction, and 92 kg per mole of heat is released, so it is an exothermic reaction. The optimum condition set for the Haber's process is a temperature 450 degrees Celsius and pressure is at 200 atmospheric pressure. Sir, back.
Okay.
We study uses of ammonia. Ammonia is used as a fertilizer. Fertilizer is a very important to improve the quality and quantity of crop. Half of the protein required to feed the world's population from plant source. Plant need nitrogen, produce ammonia. Ammonia is the only viable source to produce nitrogen. 85% of the ammonia is produced industrially, making fertilizers like urea, ammonia, and sulfate. So next, second, manufacture of H2SO4. Manufacture of H2SO4 by contact process. In this process, four steps are involved. First one is production of sulfur dioxide from sulfur. Second, purification of sulfuric acid. Third, catalytic oxidation of sulfur dioxide to sulfur trioxide. And fourth, sulfur trioxide converted into oleum and it is diluted to form sulfuric acid. In the first reaction, sulfur reacts with oxygen to form sulfur dioxide. In second reaction, sulfur dioxide reacts with oxygen in the presence of catalyst vanadium pentoxide. It is a positive catalyst to speed up the velocity of the reaction. In a reaction carried out by temperature 450 degrees Celsius and product forms sulfur trioxide and heat is released, so also it is exothermic reaction. In third reaction, sulfur trioxide reacts with concentrated H2SO4 to form oleum, and fourth reaction, oleum is diluted to form sulfuric acid. Sulfuric acid, it is used in a drug, dyes, paints, and also pharmaceutical industries. So next.
Oswald process.
Third, third, Ostwald process for nitric acid. Ostwald process means produce nitric acid from ammonia gas. In this process, William Ostwald received a Nobel Prize in 1909. In this reaction, three steps are involved. First, catalytic oxidation of ammonia to give nitric acid. Second, oxidation of nitric oxide to nitrogen dioxide. And third, nitrogen oxide to nitric acid by the absorption of water. In the first reaction, ammonia reacts with sulfur dioxide in the presence of catalyst platinum to form nitric oxide and water. In second reaction, nitric oxide reacts with oxygen to form nitrogen dioxide. In third reaction, nitrogen dioxide reacts with water and oxygen to form nitric acid. Nitric acid is used in the preparation of fertilizers like the calcium nitrate, ammonium nitrate. It is also used in manufacture of explosives, drugs, dyes, and perfumes. So next, last one, fourth, hydrogenation of oils. Hydrogenation Hydrogenation is a process in which a liquid unsaturated fat is turned into a solid fat by the addition of hydrogen. Hydrogenation is saturated hydrocarbons converted into unsaturated hydrocarbons. In hydrogenation, remove the double bond and addition of hydrogen atoms. In the reaction, Vanaspati ghee is manufactured by the hydrogenation of oil in the presence of catalyst nickel and the temperature 453 to 473 Kelvin. In this reaction, unsaturated esters means oils reacts with hydrogen in the presence of catalyst nickel to form saturated esters. In hydrogenation, it is used commercially in the manufacture of vegetables ghee from the cotton seed, coconut and groundnut. Thank you.
Okay. If anybody is having any doubt or if you want to add something in the presentation, फार छान इंडस्ट्रियल ॲप्लिकेशन सांगितले वे यू हॅव टेकन मच मोर डीपली इन द मॅन्युफॅक्चरिंग प्रोसेस ऑफ नायट्रिक ॲसिड अमोनिया सल्फ्युरिक ॲसिड सो इट इज व्हेरी इझी फॉर अंडरस्टँडिंग छान सेमिनार दिला नेक्स्ट सेमिनार विल बी कीर्ती संपाळ कीर्ती संपाळ आर यू रेडी कीर्ती संपाळ
हाँ सर
व्हिडिओ चालू करा बघू ओके जस्ट एक मिनिट आहे व्हिडिओ ओपन व्हायला लागलाय Can you see?
हाँ सर
Okay, you can start.
Good morning everyone. Today I would like to give a seminar from chemistry department. My name is Kirti Sangpa. My seminar topic name is physical property of metal. Next.
This
Shall I
is
start introduction part of metal? What is metal? Metal are element. Most of metal are solid, but except mercury in liquid. Next. Metal in periodic table. The position of metal in periodic table. The left hand side of periodic table. Gray color indicates all are metal. Next. Let's start physical property of metal. What is mean by physical property of metal? The physical property can be observed or measured without change in chemical composition of matter. This property is known as physical property of metal. Next. Many physical property of metal. First is malleable, second is ductile, third metal are hard, fourth metal are luster. Fifth, metal are good conductor of heat. Six, metal are good conductor of electricity. Seven, metal are sonorous. Eight, metal high density. Nine, metal have high melting and boiling point. Next, let's start first. Let's start first physical property of metal. Metal have malleable. Most can be metal beaten into thin sheet by hammering. This property is known as malleability. Example, gold is a most malleable metal. A solid golden sheet can be made into ornamental aluminum foil, iron, etc. Next, second property, metal are ductile. Metal can be down into thin fine wire. This property is known as ductility. Example, platinum is a most ductile metal. Another example, aluminum, copper, tungsten. Third, next, third, metal are hard. All metal are hard except sodium and potassium, which are soft, can be cut with ranip. Example of hard metal, tungsten and titanium are hard metal. Example of soft metal, potassium and sodium are a soft metal. Next, fourth property, metal have a metallic luster. Metal have a quality to do reflective light from the surface and can be polished or pose in shining appearance. Example, gold, aluminum, copper. Next, metal are a good conductor of heat. Metal have a ability to conduct heat, that is, metal are thermal conductor. Example, silver is a best thermal conductor among metal. Aluminum, copper, etc. Pose comparatively highly thermal conductors. Lead is a poorest conductor of heat. Next, sixth property, metal have a good conductor of electricity. That is, they have ability to let electrical pass through. This is known as electrical conductors. Those metal are electrical conductors. Example, silver is the best electrical conductors among metals. Copper, electrical wires that is used in our house. Another example, aluminum, electrical wire that is used in electrical post. Next. Seventh property, metal are sonorous. That is, they have unique ringing sound if you strike them with surrounding hard. This property of metal is known as sonorous. Next. Eighth property, metal have high density. Metal have a high density and are heavy. Atoms are strictly packed and the metal is very thin. Radium and osmium have a highest density, whereas lithium is a lowest density. Next, 9. Metal have a high melting and boiling point. Metal are a high melting and boiling point because the metal there is a very strong intermolecular force of attraction and they need loss of energy to melt or boil. Example, high melting point, radium is a high melting point and tungsten is a high boiling point. Next. Thank you.
Okay.
Thank you once again for listening.
If anybody is having any doubt, you can ask the doubts also. फार छान प्रेझेंटेशन दिलं. प्रत्येक प्रॉपर्टीचं with diagrammatic representation, that is very important. So ड्युरिंग these 2 seminars आपण बघितलेलं आहे की या सेमिनारमध्ये